Hello everyone. In today's session, we are going to discuss about the history of ARM processor and the architecture of ARM. Are we using these things in our day-to-day life? Smartphones, networking devices, embedded systems, embedded devices, all these things are being used by us in our day-to-day life. Have you ever thought of the processor or the architecture inside these devices? Let us see what kind of processors or architectures are being used by these devices in this video. So in today's video, we are going to discuss about the processor that is being used by the devices which I have mentioned in the previous slide. The most commonly used architecture is the ARM architecture. So this is the different versions of ARM architecture. In 1990, this is how ARM has been, the logo of ARM has been, and this is the last one is how it has now been. So introduction to ARM. ARM stands for Advanced Risk Machines. It has a significant history in the development of microprocessors, especially in the mobile and embedded system markets. ARM is being used especially by mobile devices as well as wearable devices. History of ARM. If we see the history of ARM, it early in 1980s it has started. ARM was founded in 1990 as a joint venture between Acorn Computers, Apple and VLSI Technology. Later, Acorn took over this, and initially the full form of ARM is Acorn Risk Machines. The ARM architecture originated from Acorn Computers, and later it was known as Advanced Risk Machine. And after in 1990s, it was being expanded. ARM gained popularity due to its power efficiency. That is the main advantage of ARM and performance. Companies like Apple, Texas Instruments, everything started to use ARM in their products. Then later on, from ARM 1, ARM has been developed to ARM 6 and then ARM 7. These iterations brought improvements in performance as well as efficiency, leading to widespread adoption in various devices beyond computers, that is mainly in mobile phones, tabs, etc. Then later in 2000, it was full-fledgedly used by smartphones and mobile devices. Then different versions of ARM is being used for different applications. ARM Cortex-A, Cortex-M, R series are being used for different applications. Then in 2010, the growth increased. They landed in diversified areas. They proved themselves in different industries like automotive industry, IoTs, and servers. Then they expanded the architecture version 8A, which was introduced to support 64-bit computing too. Then they started partnershiping and licensing their architectures to different companies. Then at last, now the evolution continues, and ARM maintained its position as a dominant force in mobile and embedded processors while making strides in other domains also. Now they are into AI as well. Now coming to the features of ARM. Few features of ARM has been listed here. One is load store architecture. Since it is based on registers, it uses load store architecture. Then it is single cycle execution. Every instruction it takes single cycle to execute. Energy efficiency. This is a major reason why ARM is being used in many portable devices. Then scalability, it is being used in mobile, smartphones, tabs as well as in the laptops too. Customizing and licensing is also being provided by ARM, that is a special feature. Then it supports multi-core. Then different variants, as we have seen, ARM Cortex variants are also available with ARM. Support for 32-bit and 64-bit computing is also available. Then it is adaptable for various operating systems, for Linux and everything it has been used. Then it is highly reliable and security for whichever operating system has been. Now coming to the ARM architecture. This is ARM architecture is very simple. ARM, so it includes the register bank. It has an ALU, barrel shifter, multiply register, incrementer, address register. Then it has instruction decoder and control unit along with the data out and data in register. The way how it it works is it has an ALU. The ALU receives input from the barrel shifter as well as the register banks. The barrel shifter and the multiply register are a very important feature of ARM. It can perform multiply and accumulate unit in a single cycle. In a single cycle, it performs multiply accumulate unit. That is, the barrel shifter performs shifting operations and addition operations in a single cycle. This is a major feature of ARM which speeds up, that is, which improves the performance of the system. Then it accesses every instruction from register banks. Then it has incrementer where the PC address has been used. It has two buses, A bus as well as B bus. Then instruction decoder and control unit are being used to decode the instructions as well as to generate the control signals. Data in register is used to receive every data, so whatever is coming into the processor, as well as data out register is used to take out the data after processing from the ALU. So though the architecture is very simple, this barrel shifter and multiply register plays a major role in improving the performance of the system. Also, ARM supports pipelining. That is also another major advantage of ARM, which improves the performance too. Coming to the registers, it is a register-based load store, and so we have to speak about the registers too. It has 37 registers, each of which are 16 bits. And using these registers, the ARM can work under 7 different modes of operation. One is user mode, another one is system mode, another one is supervisor mode, then abort, undefined, interrupt, and fast interrupt mode. In all these modes, R0 to R12, the registers are common, and the remaining registers are used for program counters or stack registers, or it can be used as CPSR, that is current program status registers. So for all these other things, other registers are being used. Coming to the advantages of ARM, it is a low power consuming architecture or device. So better battery life it has. That is the reason why smartphones and wearable devices uses this ARM. It works faster. ARM performs single operation at a time. Though it has reduced instruction set, but it performs single operation at a time. Low latency, that is quicker response time. Multiprocessing is also available. So I hope you understand the basics of ARM, the history and architecture we have discussed about. And this is a small assessment for you. RISC machine, reduced instruction set computing. And what is a barrel shifter? It's used to shift digital values either to right or left one in a clock cycle. Thank you.